Now, in this question, it is asked that the geometries of HgI3 minus and SnCl3 minus respectively are. So, option 1 says trigonal planar and trigonal pyramidal. Option 2 says trigonal pyramidal and trigonal planar. Option 3 says trigonal planar and tetrahedral. And option 4 says tetrahedral and trigonal pyramidal. So basically we have to find out the geometry of HgI3 minus and SnCl3 minus. So we will apply vsepr theory here also to predict these geometries. So first is the HgI3 minus compound. So mercury. Now we know that mercury is in the 5D transition series. Okay. So 5D transition series, and it is the last element of the 5D series. So it has a valence electronic configuration of ND10. So D is completely filled and N S2. Actually it is 5D10 and 6S2. The number of valence electrons we consider as only 2. Okay, now so from this we know that Hg is the central atom. Now what about the electrons gained from iodine? So we have 3 iodines bonded to Hd here. So 3 electrons from iodine. And then we have one negative charge also in this complex. Okay, that will also be counted while counting the total number of electron pairs. Okay, so how many we have? Total number of electron pairs. So we have 2 from mercury, 3 from iodine and 1 negative charge. So we have 6 electron pairs. So now we are talking about electron pairs. So we divide it by 2. So 2 is equal to 3 electron pairs. And this corresponds to which geometry? So 3 number of electron pairs correspond to sp2 geometry, which is actually trigonal planar in shape. And now what about the bond pairs? Number of bond pairs is how much? So we have 3 iodines bonded to mercury. So 3 bond pairs. And then what are the number of lone pairs? So total number of electron pairs is also 3 and number of bond pairs is also 3. So lone pairs is equal to 0. So there are no lone pairs. That means this HgI3 minus will have a regular trigonal planar geometry, and then we can arrange it like this. So here is the central mercury, and then in a trigonal planar fashion these 3 iodines are bonded to mercury and then a negative charge. So the trigonal planar geometry is for this compound here. Okay, so the first part of the answer should be anything from 1 or 3 option. Trigonal planar. Now coming to the second part of the question, that is SnCl3 minus. Now in SnCl3 minus, what is the central atom? Obviously tin is the central atom and it belongs to the carbon family. So what should be the valence electronic configuration? So carbon family means it should have ns2np2. So 2 plus 2, 4 electrons should be in the valence shell. Now, how many electrons are coming from the bonded atoms? We have 3 chlorine atoms bonded to Sn. So, 3 electrons from chlorine. And also we have a negative charge. So, total number of electron pairs should be, so 4 from tin, 3 from chlorine and 1 negative charge divided by 2. So, 8 by 2 is 4 total electron pairs. And how many bond pairs? So 3 bond pairs and how many lone pairs? So total number of electron pairs minus bond pairs is equal to lone pairs. So we have 1 lone pair. Now, if we have a total number of electron pairs as 4, so this corresponds to sp3 hybridization, which has a regular tetrahedral structure. But if this regular shape, we have a lone pair of electron, then this regular shape is distorted. So because of this lone pair, so tetrahedral is distorted to what? Pyramidal structure. So it is similar to the geometry of ammonia, if you recall from vsepr theory. So now if we arrange SnCl3 minus in pyramidal shape, it should look like this. So we have the central atom Sn, and then we have 3 chlorine atoms attached like this, and then we have a lone pair here arranged like this. So the parent geometry is tetrahedral, but due to the single lone pair, this geometry is distorted to the pyramidal shape. Now let's go back to the question. So we had earlier predicted option 1 or 3. So in option 1, it is given the second compound's shape as trigonal pyramidal, and in option 3 it is tetrahedral. It is given as tetrahedral. Okay, so we just saw that the shape is pyramidal for SnCl3 minus. So the option 1, this option should be the correct answer for this question. And this is also one of the questions that has been asked in a competitive examination, and it should be helpful for you to solve such questions. And I think the explanation was quite clear to you, and hope it is helpful. Thank you so much.